Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with DevExpress controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com.
From hanselminutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 537. In this episode, Scott talks with Rachel Simone Weil about programming for the Nintendo Entertainment System in 2016.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today, I'm talking with Rachel Simone Weil, who is an NES or a Nintendo Entertainment System ROM artist. Is that a fair description?
That sounds good. Hi, and thanks for having me.
This is really cool. I'm trying to get my head around this. So you make new, fresh Nintendo games in 2016.
Right, for the NES, which came out here in the US in 1985.
So that's 31 years?
Yep.
And is this something you started 31 years ago, or when did you decide that this was something you wanted to get into?
When I was a baby.
Yeah, exactly.
I became interested in the NES probably in the mid-90s. So after its heyday, after that console had kind of come and gone. Mm-hmm. And I never had one as a kid, but when I was a young teenager, I started seeing them pop up at garage sales and things like that. And so now it was pretty affordable for me. And I got my first game consoles all through garage sales and things like that. And I think at the time there was really no concept of retro gaming. You know, like people didn't think that there was any reason to keep an old game console. It was like, hey, the PlayStation's out. Why would I want this, this, old 8-bit system or old 16-bit system? So that's kind of how I got interested in games. They were kind of old when I started, and pretty much as soon as I started playing these games, I was thinking about ways to modify them and ways to hack them, ways to change them. And once I started playing around with that and saw how fun it was, I had to know how these games were made from scratch. And so I taught myself assembly and started a journey that's been going for about 5 or 6 years.
Oh, wow. So these were old when you started, which I think is awesome. It seems like there's a renaissance now, a reappreciation of old systems of all kinds.
Yes, exactly. I don't know when the retro craze started. I feel like maybe it was in the late 1990s or early 2000s when people wanted to go back and play those games. And I think it's really interesting, not only like wanting to go back and play games from your childhood, but also like thinking about ways to change your childhood. Or, I think a lot of people who are interested in hacking old games or making new games for old consoles, thinking about how could I take my childhood memories and kind of play with them, or, make the game that I wanted to play when I was a kid or something like that. I think there's a motivation like that behind a lot of, what I do and what other folks in the homebrew community are doing.
Mm-hmm. I will say, though, that as a cartridge-based system, both now as an adult and as a kid, it seemed more closed. It seemed impossible. Like there was something required that I didn't have, some magic part of the thing that makes the cartridges. It somehow seemed more closed than even like an Xbox, where I feel like I could talk to it with a network, or I could burn a CD. Making a cartridge or getting my own code onto it seems impossible.
Absolutely. And that was definitely by design, in some respects. So, I think, Nintendo in particular, when they released the Famicom, which, Famicom was sort of the NES in Japan, came out a few years earlier. When they brought that console to the American market, they were concerned about things like piracy and low quality games from sort of questionable developers. And that had happened with the Atari 2600. It was much easier for small studios to make games for the Atari. And so you ended up seeing a market that was flooded with games that maybe weren't quite that good. And so Nintendo was, I think, very smart in wanting to sort of close that system off. And so you do see, like, of course, the cartridge, right? It's a tool that, or it's a sort of medium that's it's not easily accessible. But I think there were other things too, like not even small studios were really able to develop for that system. You had to get permission from Nintendo, right? You had to be an officially licensed developer. You had to pay money to have the privilege to develop for the NES console. So it was, of those cartridge-based systems, it was one of the most closed off. And it's also a reason, one of the reasons that Nintendo continued to have cartridge consoles up through the N64 when the PlayStation had moved to, disc media.
Yeah, and there's rumor that they may go back to cartridges even now.
Yeah, I can't speculate on that, but it would be interesting. There are definitely some benefits in terms of, performance. There's trade-offs with size, what you can fit on a cartridge, but.
So you have to be a licensed developer, but what does that mean? You get a fancy cartridge burner thing or a ribbon cable that shoves into the NES and then you write your code on the computer and then it feeds into the ribbon cable that feeds into like a pretend cartridge?
Well, back in the day, Nintendo actually produced every single cartridge in their Japanese facility. So it wasn't like, they really, had a lot of control over the manufacture of the cartridges. So it was very, very difficult for anyone who did not have Nintendo's sort of blessing to go make a cartridge. Now, it did happen. There were a couple of companies that did make unlicensed cartridges. Not only was the manufacturing an issue, but Nintendo had also put a security device in the NES, and it needed it was kind of a lock and key system. So there was the security device in the console, and then there was one in the cartridge. And since Nintendo controlled the manufacture of the cartridges, they put that security device in the cart. And a couple companies figured out ways to get around it. Some of them would send a little voltage to that security device to temporarily disable it. And then another company actually reverse engineered it and sort of made their own keys to put in the cartridge. That company, as it turns out, was Atari, and they got sued for taking patent information and using it to reverse engineer the security device.
So what did people write their code on, though?
What did they write their code on? The Atari
back in the
folks?
day, like you said that. No. When you wanted to make like you said that the cartridges are locked down and there's security keys and they manufacture them themselves. What were people doing? Like, were they writing them on emulators, or how were you testing? If you can't just make a cartridge every time you want to test. Yeah,
I'm not certain. There's not a lot known about the development process. I think it was a lot less sort of public knowledge. There were certainly, I've seen for some consoles they had developer kits, like special hardware that had, sort of special feedback or inputs. I know there were also development cartridges. It could be that that developers were burning their own cartridges, just using basically an EEPROM burner. But I don't know too much about the development, in terms of like the hardware, what computers were they using? That would be really interesting to find out.
Yeah. Well, how do you do it then? Like, do you program on an emulator? And then when does it move from an emulator to the real device?
Yeah. So the process is essentially, I start out in a simple, like, code editor. Notepad is totally fine. I actually use VS Code because it has an assembly language syntax highlighter, which is pretty handy. So I just start kind of writing the code from scratch in there. And, when I feel like I've got something that will turn the screen on, basically, I can start testing in the emulator. So, there's a really simple, there are a couple NES compilers, they're all community created. So, none of Nintendo's original tools are out there. So everything that homebrewers use to make NES games today, was made by the community. So, there's, of course, a compiler that compiles NES code. There's also things like, graphics editors and sound editors and things like that. Again, I imagine that they're similar to what real developers were using, but I'm not certain. So yeah, I can actually test that code in the emulator. Debugging, they've actually written emulators with debugging tools and, a live hex editor. I actually usually do most of my debugging with a live hex editor. So I know what's kind of cool about assembly language. And once you're really familiar with the architecture of a system, I can actually open up the hex editor and look at the values in RAM and go, oh, there's my sprite. It's not incrementing, right? I know exactly what address
Really?
it's at. And that's pretty much how I debug. There are people have built more contemporary debuggers where you can set breakpoints and things like that. But, once you've written into assembly, you kind of know where everything's at. So,
Well, because it's finite, right? It's not gigabytes of memory there is a limited amount of space for you to look in, isn't there? You could almost, with a really big monitor, see all of memory.
you'd have to have a pretty big monitor or a pretty small font, but yeah, most of my games, are right around 32 kilobytes.
Uh-huh.
I think the biggest one I've done was maybe 256, and all of that was because of music.
So there's an addressable limit of the CPU then on an NES, right? Which is like 64K.
Well, it kind of depends. So, you've got, it's a complicated formula, right? You've got the console, which, it's, 8-bit, it has 16-bit addressing. And it's got so the console itself has a certain amount of onboard RAM. And then you've got the cartridge, which can sort of vary. Typically you have, so you have graphics and your game code, your logic sort of separated onto two different chips. And those, typically come in sort of 8 kilobyte chunks. And so what you see is a lot of, and eventually over time, those cartridges had greater capacity. And they also had, special mappers, which would allow things like bank switching. So maybe you had, 64 kilobytes of graphics data that you could swap in, 4 kilobytes at a time. So you'd kind of shuttle some stuff over into RAM and, on the console, and you could work with that for a while, and then you might bank switch and shuttle some new stuff in. So there were a couple of different limitations, both on the console side and the cartridge side and the mappers and things like that were sort of developed and made more cost effective over the lifespan of the NES.
So let me see if I understand this. So the CPU inside of the NES, you program 6502 assembler. That's the processor flavor of assembler that you're writing. And the CPU has an addressable range, like, some processors, like some machines had a 4 gigabyte addressable range. That's how much, address space they have. 32K of it can be mapped into a ROM, which is the cartridge, and the ROM could be arbitrarily large, and then you swap in chunks. You bank switch in chunks into that higher address space, that 32K address space.
Is it 32K? That's the only number I'm not certain of. But the basic outline you give is correct.
There's like a lower half and an upper half, and then the upper half you swap views onto this larger pile of data that you have available to you in the cartridge. Like, could be other levels, right, or other music or other stuff. Right,
exactly. And typically, so the NES is tile based, so you're bringing in graphic tiles. It's pretty interesting the way that the NES separates out graphics code from the rest of the sort of game logic. One really cool thing you can do as like a really, if you wanted to get a simple ROM hack in, you can open up a cartridge and get your soldering iron and a desoldering braid and take out the graphics chip on one cart and swap it with another one. And so because the graphics and logic are completely discrete, you can have, Excite Bike, but, with the graphics from a Ninja Turtles NES game or something, right? So the logic will still operate exactly the same. It does not care what those tiles are really made of.
It doesn't notice that you messed with it. Like you pulled its brain out and put it into a monkey.
Right. I think, there's some limitations, like, typically you want those, I haven't experimented to see what happens if you don't do it this way, but typically you want those banks to be the same size and have the same kind of board, right? Like if this one has such and such mapper, you probably want the one you're grabbing it from to also have the same mapper and things like that. But yeah, I've actually, I did a hack called, Excite Ball, where I just took the Excite Bike cartridge and replaced it with the graphics from baseball. And so you see these bikes going by on the track and they're all made out of baseball players. And,
that's awesome.
The bike animation, it works by tiles that swap out, a couple times a second, let's say. So instead of seeing a bike wheel spinning, you don't really see a baseball player spinning because it's not, the tile itself isn't spinning. It's just flipping between, one sprite of the wheel and another sprite of the wheel. So now what you get is, just flashing sprites all over the place where it was once animation. It's pretty fun. It's simple.
Does that mean that they're in the same location?
Right. Exactly.
Like if I swapped out, and forgive my Nintendo ignorance, like a Mario cartridge for Mega Man or whatever, like, does that mean Mario's body and Mega Man's body were in the same place?
Only if Mega Man's body actually replaces Mario's body. So the tiles are kind of picked, let's say, between 0, 0 and FF. And the game doesn't really care what's where. It's just saying, hey, I want tile 10 and I want tile, D-teen. And whatever's in there, I'm going to grab and stack it together. And that's going to be my playable character. So.
Did you just say D-teen?
D-teen, yeah. So it's,
that's awesome. I've never, that's so much better than what I've been calling it for the last 30 years.
What have you been calling it?
D3.
Oh no. So for me, D-teen is 1D. Right? So it's like 10, 11, 12, 18, 19, 18, B-teen, C-teen, D-teen, E-teen, F-teen, 20.
Oh, you're awesome.
But then when you get past
then what is A7?
90, that's 87, which sounds a lot like 87. So it's kind of confusing. But you have, 80, BD, CD, DD, ED, and FD, right? So FDF for like FD5.
Yeah.
I learned assembly on the streets, like IE and so, and it was my first programming language actually. And so I think I developed a lot of idioms kind of in my head and
But now they're going to be things like, is D-teen a thing or is that a Rachelism?
I don't know.
It's a thing now. We're going to make it a thing. We're going to hear from some assembly people that are like, yeah, back in the 50s, I was saying D-teen.
Back in the 50s.
I don't know. So, I just went, and I think people who are listening should do this as well, and I'll put the links on the show notes. I went and I downloaded FCEUX.
Yes.
So FCEUX took me 2 seconds. It was a nothing little, it's a Famicom / Nintendo emulator. It looks like it hasn't been touched in like 3 years. And then I went to your GitHub, which is Hexcellent, HXLNT. It's GitHub/HXLNT. And I went to your computers are easy, which is funny because I just did a blog post about how they're not. And you did a program written in assembler showing that they are quite simple. And you've got all the source code for a great kind of hello world on steroids. It's got music and sprites and user input and color cycling. I downloaded the raw version of your loveiskind.nes. I went file open and I'm running a Nintendo app. This was 4 minutes from start to finish. But the part that's amazing to me is that you go to the debug menu and you say hex editor. And what am I looking at?
Yeah, so this is really cool. So this emulator FCUX has debugging tools built in. Again, these are all community made. And you've opened up the hex editor. So there are actually a couple different views you can see in the hex editor. And, I don't have it in front of me, so I'm going by memory. I think it's like file, or maybe you can switch between PPU and, looking at the raw file.
I see NES memory, I see PPU memory, and I see ROM file.
Yeah. And you're looking at NES memory right now?
Yeah, and it's changing. It's turning color as I see, like the app is running and things are flashing on the screen, and some values are just staying all 0 or FE, and other ones are spinning in red.
Yeah, so this is really
cool. Things are moving. I'm looking at the matrix.
You are looking at the matrix, and this is actually how I debug my code, looking at the matrix also. It's pretty cool. So what you're seeing is actually the values in the memory being updated live as the game is running. So I just happen to know that the first couple rows of memory there are handling music. So there's some about 16 bytes or so that hold music data. So what you should see, if you've got the game running next to the live hex editor, you should actually see those values changing with the beat of the song. They are.
There's two specific ones that are the 1, 2, 3, 4, 5. So what is that? 5. It's 5 bytes over and 7, and they seem to be together like a drum beat.
That's
just
probably
going
right.
Boom, boom, boom.
Yeah.
And then there's a whole lot of zeros, and then there's like a whole bunch of stuff that's changing in one section from 200 to 300.
Right. So a couple things that are happening there. So you've got your music values, which are changing. NES does music with 2 square wave channels, a noise channel, drum channel, which is a noise channel. And then there's an optional, sort of wave-like channel, which I didn't use for this one. But those first 16 bytes or so are my music RAM. And then I've got after that a couple of variables that I created myself. And, one really important one is a timer. Right. So this is a really interesting thing. I always like quiz my friends who, are, like normal programmers, game developers and people working on systems that are like not 30 years old. And I asked them, how do you get a random number in an NES? Or, how do you know, like how much time has elapsed in an NES game? And they're like, well, you just call the clock. And it's like, well, there's no clock, right? So one of the most important things I do in every NES ROM is I set up a counter. And, the game may not necessarily know where it is in its cycles. You may not know if you're running out of cycles before the next screen refresh, which if you're trying to update graphics while the screen refreshes, you'll get corrupted graphics. So that's bad. So yeah, I keep a counter going, and it helps me, keep time in the game. So I basically have a variable called, I don't know, NMI counter or something, and it increments once every time, the console hits NMI. So I know essentially it's going to be running, I'm going to have that value get up to 60 in 1 second, right? 60 times a second is a sort of, if you think about 60 hertz, right? Refresh rate. And so I could extrapolate from that and figure out, okay, well, if it gets up to 60 in 1 second, then I can figure out what it's going to get up to when it hits 1 second, and then I can create sort of a second timer and things like that. So when I want my animations to look really pretty, I don't want them to flip around 60 times a second because you couldn't see that, right? So I need to create timers. So my sprites, let's say I have someone walking, or in the case of this ROM, I have some hearts that kind of bounce to the rhythm of music. And I want those to be animated, but also animated slowly enough that they're visible to the human eye. So I use those counters to keep track. So what you'll see in the hex editor is there's some numbers that are just going from 0 to FF incredibly quickly. And that's that NMI counter that I've created to keep time.
When I look at the source code here, you have sections where you have like, it looks like you're saying 1.0 and 2.0 and 3.0, and you're basically chunking off little sections of stuff. There's a couple of starter bits of things where you say, you know, here's how big the cartridge is. And then you've got music. You say, here's 16 bytes for music. And then I'm struck for some reason by right next to it, it says buttons, you know, .rs1. So you have the whether or not the button is pressed literally sitting next to the music. Like it couldn't be any closer. It's the next byte.
Right. And what's interesting too about the button reading on the NES is, of course, you don't want to read every button press. You want to read the first one, and then you want to hit a flag, and then you want to wait for that button to be released. These are things I think a lot of game developers are really spoiled with now. It's like, oh, just let's see if X is pressed. But if you think about it, you don't want to type the letter X every time a button is pressed. You want to type the letter once and then maybe wait a few seconds or a few milliseconds, and then maybe you want it to make another X, or maybe you don't, right? And so I don't have the source code in front of me, so I'm going by memory, but I think I actually might have a couple of variables related to buttons because I need to store previous, the values from the last CPU cycle and the values from the current CPU cycle and compare them. And I'm doing, sort of bit shifting and things like that. So, So yeah, it's, no libraries, no handy functions unless you write them all yourself, and button presses are pressed.
You've got buttons pressed, then you've got buttons pressed but not read, and then buttons pressed that need to be read.
Right.
And there's like 5 or 6 lines of assembler that dance around I want to make sure that are you holding the button down? Are you just tapping the button? You're right. Like when I learned this stuff a long time ago, we always talked about debouncing. And keeping track of whether you push the button too many times or holding the button down and making weird stuff happen, or filling up buffers full of button presses and then not being able to control it. You're really on the metal here. Like there's nothing underneath there. There's no layer of abstraction. There's no libraries. It's just you and some hardware.
That is absolutely correct.
Is that why you like it so much?
I do like it a lot. It makes a lot of sense to me. And I find there's an analog with, something that happened to me when I was an undergraduate. So I started out as a biochemistry and genetics double major, and, started taking, freshman genetics and got into sophomore level, and they would always draw genes as these boxes connected by string. And I would say, well, what is this box? And the professor would say, well, it's a gene, and this gene moves over here and this one goes over there. And it was, well, what's inside the box? And they would say, well, I don't know. That's chemistry. That's not my problem. And so I switched majors. I became a chemistry major, and I found out what all was in the box. And I was, of course, really interested in genetics still, but, I guess my kind of mode of thinking can be a little bit all or nothing, which is a good thing sometimes, a bad thing other times. But for me, I find with other programming languages that, I have since learned other languages, but I always want to know what's in the box. When you write console.log, like what's actually happening? What does that mean? what are the ones and zeros behind that? I know it in assembly, but JavaScript, there's a lot of layers, a lot of black boxes.
Yeah. And it's easy when I think about the various kind of generations that, and generations of programming languages, generations of computers, but also generations of programmers. It's interesting to see who is interested in what they think the metal is and how far down it goes. Because there's a whole new world now with asm.js, where there are programmers who are coming out of school now who think that JavaScript is the metal, and they're going to write to asm.js and believe that they're on the metal. And then the question is, from a matrix perspective, is, well, maybe they are on the metal.
Mm-hmm.
I mean, maybe it's just their metal. And I don't know what I feel about that. I think I'm always going to want to know what's underneath.
Mm-hmm. Yeah. And it was super fun, when I used to teach at the University of Texas, a course on video game history. And we would open up an NES and we would look at, we would open it. I brought screwdrivers into class, right? All right, let's sit down and take this apart. And a room of a number of computer science majors and electrical engineering majors who had never seen we could actually point to, this is the place where Mario gets stored. And this is the watch battery that, keeps the values in RAM for your save game. You can point to the actual coin cell battery. You can point to, here's the CPU. And it's really cool when you see it like that. Something that I think, a lot of them hadn't really ever seen before.
Yeah. Being able to point on the board and say, this memory is that chip, is really significant. I remember buying memory for a 386
mm-hmm.
and a 286 before it, and we would buy it we'd buy the actual dips, and you would say, okay, well, here's 16K of my 4 megs. I'm putting 4 megabytes in this computer, and here's 16K at a time.
Mm-hmm.
And I would put each chip down, and you would go and run a bank test. And I think you see those when you boot up some arcade games, some older arcade games.
Mm-hmm.
It'll show you I am physically testing that chip on that part of the board, and it would light up a square and say, if that one goes bad, swap that one out.
Mm-hmm. Mm-hmm.
Gives you a whole perspective on how this, i7 16 gig of RAM machine that we're talking on right now actually works.
Right.
Is this something people should start? Do you think that you need new, fresh voices in the NES homebrew community?
I would always say, yeah. I would always say yes. I think, people have different reasons for getting into homebrew, and I think a lot of them are nostalgic. Not all of them. There's certainly homebrewers that are, working on consoles that were before their time. The NES is kind of that way for me. I think what's really interesting to me about homebrew is when people take their childhoods and people take history and they sort of play with it and they sort of rewrite. It's kind of like the sci-fi of homebrew. When people say, well, what if we went back to this era and we just made something completely different than anything that ever existed? Let's put aside platformers. Let's put aside action games. One of the games that I made was a horoscope game, fortune teller, love compatibility tests, really super girly and pastel. And it's pretty different than what the NES library looked like. There was one sort of obscure tarot card game that came out in the US for the NES, but for the most part, it's pretty kind of an unusual genre, one that didn't really appear otherwise on the NES. And I love that kind of thing where you sort of reimagine history and maybe you make your own sort of utopia or your own sort of new and improved version of history. That's, I think, for me, the great power of things like sci-fi and movies and film, and why not do that with games too?
Didn't you do a hack where you swapped the gender of a character out in a cartridge?
Well, I did do Mega Man, which was was a gender bending Mega Man.
Awesome.
Certainly not the first. People have been doing gender swaps in NES ROMs for years. I've actually done some research on that and published a little paper about it. The other one that I did, which was quite silly, was I guess I did a couple. I used the Barbie font, the font from the NES Barbie game, and put it in Mega Man. And it's one of those things where it's a little tiny change. The type is 7 pixels high and 7 pixels across, more or less. But it's very disconcerting because Mega Man, it's one of those iconic games and you have an idea of what it looks like and you see this slightly italic typeface and you go ugh, Mega Man's broken. There's something wrong. And I was kind of interested in sort of this idea of like, what's the minimum change you could make to Mega Man where it's almost like just eerie,
subliminal.
like it just, there's something really wrong with it. And that typeface was pretty effective, at doing that. So yeah, I don't know. I kind of like to play with stuff like that. I was, incredibly girly as a kid, like always wore frilly dresses and stuff like that. But I was also a tomboy and collected baseball cards and things like that. But I always like to play with that aspect of my childhood where kind of mix and matching, the really girly stuff and the sort of more boyish stuff. And, I'm a big fan of Barbie and Hello Kitty and all of that stuff. So I like to play with that a lot. I guess one of my more
fantastic. Famous
hacks was putting Hello Kitty into Super Mario Brothers, and making the whole world
as a character
pink and
or as a goal.
And, what's that? Yeah, replacing Mario with Hello Kitty, and just making everything really cute. I also made Kitty jump really high. I did this one in high school. It was my first ROM hack. And, she can jump very, very high. So she can actually jump over the flagpole at the end of the level, which if you do that, and you walk past the flagpole, you can't walk backwards in that game. So you're just eternally stuck in the screen until time runs out and you die.
Cool. Well, one thing we didn't get a chance to talk about, but people can go and explore, is your kind of now legendary connected NES hack, where you basically built a Twitter client for NES, and it was a wireless modem that connected an NES to the internet. It was really, really clever, and it was also a talk that you gave at OzCon, the open source conference.
That's right. Yes. Please check it out. It's all on GitHub.
Yeah. So I'm going to go ahead and put links in the show notes to your GitHub, which is HXLNT, and people can explore that and some of your videos on Channel 9, and check out your code and hopefully become new NES ROM hackers and developers.
Yes.
Thanks so much for chatting with me today.
Thank you for having me.
This has been another episode of Hansel Minutes, and we'll see you again next week.